In this video, we're talking about a different type of function. They're called reciprocal functions, where a constant or polynomial is divided by another polynomial. So here we're starting to introduce fractions. The simplest rational function that we have taken a look at in the past is y equals 1 over x, or f at x is equal to 1 over x. Rational functions generally have something that are called asymptotes, which are lines that a curve approaches but doesn't cross. You can have horizontal, vertical, or oblique asymptotes. Asymptotes occur when there is a break in the domain. So for example, our function is undefined here at x equals 0, which means that our domain would look like this below. This is an interval notation. We also say that because there can never be an x value of 0, we also say that there's an asymptote, and we represent asymptotes using dotted lines that you'll see on the graph below. So if I take a look at this first example, the first thing that I'm asked to do is graph y equals f at x. F at x in this case is x plus 3, which is a line with a y-intercept of 3 and a rise over run of 1. So I can put on, I'm going to use green to do this one. I'm going to use a ruler to connect the dots here. Oh, maybe not. Okay. You would use a ruler. Here we go. There we go. Okay, y equals x plus 3. Now I'm going to graph the reciprocal of that. And so in order to do that, I'm going to identify some characteristics about that. So my reciprocal function is 1 over x plus 3. Really, in order to find the reciprocal, I am going to do 1 over the values that I get here. So if I pick, let's say, 3 values here, I can make a table of values. This one is x and f at x. Let's do 1 over f at x. And then I'll use my green and I'll write up here to match my original function, x and regular f at x. So my first one that I know is, let's choose the x-intercept here. So I've got minus 3 for x, and then I've got 0 for f at x. And then I've got, as x is 0, y is going to be 3. And then I'm going to choose another one, 3 and 6. So when x is 3, y is 6. So I'm going to look for some key points here. My x's I'm going to leave the same. My y's, I'm going to notice, well, 1 over 0, I can't have that. That is undefined. That means I have an asymptote. 1 over 3 is just a fraction, 1 over 3. 6 over 3 is 2. So I know that I've got an asymptote at x equals 0 for my reciprocal function. So I'm going to put that vertical line on at x equals 0. I can't get to that one. I also happen to have a horizontal asymptote. This is something you don't really know yet. But when you have a 1 on the top, you always have a horizontal asymptote at y equals 0. The next thing that I'm going to put on is these points that I plotted. So I've got 0. So when x is 0, I'm going to have a third, and I've got the wrong asymptote here. So let's change that. Because I noticed that when I did put in 0, I had a third. So I'm going to add that point. And I'm going to go back to my asymptote. It's not that when x equals 0, I have an asymptote. It's when x is equal to -3. So I'm going to redraw my asymptote still as a vertical line, just at x equals -3. So it's in the right spot. And then I'm going to notice that I've got 3. And when I put in +3, I'm going to get 1 over 6 here, which is not the right value. There we go. Okay, 1 over 6. So now I get a smaller fraction. So I can identify that on this side, it looks like my graph is approaching my asymptote here. On the other side, I told you that it approaches but doesn't touches the asymptote. And then I need to know what's happening on the left side of my graph here. So I need to know what happens on the left side of x equals minus 3. So I'm going to add a little bit more to my table. I'm actually going to draw another one beside it here. And I'm going to substitute in some values that are on that side. So I'm going to take a look at minus 4, minus 5, and minus 6. I know that when I substitute into 1 over x plus 3, this is going to equal, so 1 over x plus 3 is going to give me 1 over minus 1, which is minus 1. 1 over minus 5 plus 3. Okay, so I'm just substituting into where the x is going to give me minus a half. And then I'm going to get my last one here, 1 over minus 6 plus 3 is going to be minus 1 over 3. So those numbers are getting smaller and smaller into the negative fractions. So minus 1 over 3, I'll put it up here. So I can plot those points on here. So I've got minus 4 and minus 1. I've got minus 5 and minus a half, minus 6 and minus a third, and then I can infer that they're going to approach my asymptotes on either side. The shape is constant for all of them. My domain is all of my x values, so that goes from minus infinity to minus 3, and then continues on the other side from minus 3 to positive infinity. The range is all of my y values, so it goes from minus infinity to 0, and then from 0 to positive infinity. My vertical asymptote I already found was x equals minus 3. The horizontal asymptote I told you was y equals 0. My intervals of increase are the ones where it looks like I'm going uphill. I'm not going uphill in either of these situations. Both of these ones would be if I started right at the top, right here, and I went down this way, it would be like I am going down a slide. If I went on the other side, same thing. If I started here and went down, I would be going down. So I'm decreasing on both of those intervals from minus infinity to minus 3 and minus 3 to positive infinity. And then intervals of increase are none. I'm not climbing either of those parts of the graph. The last piece is the positive part. That is where the graph is above the x-axis, which is the part that I am highlighting in blue, from minus 3 to infinity. And then the part that I'm going to highlight in, let's use black, this part right here, all of those y values are below the x-axis or they are negative. So that is from minus infinity to minus 3. And that is an example of a reciprocal function.